Hey guys, welcome back to another Nice Lectures video. Today is going to be a quite short one. Today we will be talking about Hess's law. This is another chemistry topic, and let's get started. So the definition of Hess's law is such. Hess's law states that the total enthalpy change, which we know is delta H, for a reaction is the same no matter if you add, subtract, reverse, or flip the equation. What this means is that this is a concept in law that is used in different chemical equations when you want to figure out what is the total enthalpy change. What is the delta H of an equation when you're trying to make like other chemical reactions. And we'll actually see how this applies into rules and how it is used in actual practice. So some base rules for Hess's law, and just stay with me if you're confused. Just stay with me. So, the Hess's law, some first rules about Hess's law is that, number one, if you flip the reaction, you must change the sign of the delta H. And we're going to see how this is placed in the practice problem later. So, if you flip the reaction, if in any case you need to flip your reaction, meaning flip the reactants to the products to the reactants, you must flip the sign. For example, if you have A yields B, and this is the enthalpy change, delta H is positive, if you want to flip it, meaning B yields A, then the delta H would be negative 50. This is just a rule. And then another rule states that when you multiply the reaction, like when you multiply the reaction, you multiply the moles of a reaction, you must multiply the value of delta H. For example, if you have something A yields B, a reactant yields a product, the delta H for this is positive 50. If you want to multiply the reaction, meaning multiply the number of moles in the reaction, so 2 moles of A yields 2 moles of B, you must multiply the delta H as well. Now let's do an example problem. So this example problem asks us, find the delta H, or the total enthalpy change for this chemical reaction. This chemical reaction is carbon plus 1/2 oxygen, 1/2 mole of oxygen gas yields carbon dioxide. And then it's giving us some given statements. So we are going to use these given statements to find what we need. This is what they're asking for. So this is what we're going to try to find. Our given statements show that 1 mole of carbon plus 1 mole of oxygen gas yields carbon dioxide, and that carbon dioxide plus 1/2 mole of oxygen gas yields carbon dioxide as well. Now, what you would do in these types of problems is that you need to find a way how to manipulate these chemical equations that they've given you to make this chemical equation. You can do that by a multitude of things. You can do that by adding, subtracting, reversing and flipping, and blah, blah, blah. And then keep in mind, we will need to be following all of these rules as well, because those are important. So my first things first, I want to look at where everything is and what I need to go. So one rule given is that I see here I have like 4 different types of things. I see that I have C, I have O2, I have CO, then I have CO2, right? But in my goal equation, what I want to call is my goal equation, I don't see any CO2, meaning that I need to find a way to cancel the CO2. Well, how do you cancel, you ask? It's very easy. All you have to do is that you need to flip at least one of the equations in order to cancel them out. Meaning that if I flip one of this equation, I can just flip the reactants to one side and the products to the other side. And we know by Hess's law, it does not matter that total enthalpy change does not, the delta H won't be affected if you flip the equation, meaning that if you say CO2 yields C plus O2, your enthalpy change your delta H won't change. So keep in mind that we will need to be canceling out that CO. Okay, now I need to think about where my other things are. So I know that I need my carbon oxide to be on the right-hand side, but on here, it's on the left-hand side. Meaning that I know for a fact I need to flip this equation. Why? Because I need to get this to the right-hand side and this to the left-hand side so that I can cancel my CO2s. Now I'm going to go ahead and rewrite my chemical equation, so C plus O2, we agreed that we weren't going to do anything to the top equation. And then we're going to flip this one. So CO2 yields CO plus 1/2 O2. Now, from here, I can cancel out my CO2s because they're just redundant. They perfectly match and cancel each other out. And then I know that I'm going to look about where everything is. So my CO is on the right-hand side. That is correct. My carbon is on my left-hand side. That's correct. Then I have an O2 over here and an O2 over here. As I said before, when two of the same element are on opposite sides of that yield sign, you can see that this one's on the left and this one's on the right. They basically cancel each other out. But wait, these aren't the same number. This one is 1. This one says half. Well, they still cancel out. It's just that for every 1/2 mole of O2 on this side that gets used up, there's still 1/2 on this side that is left over, essentially. Meaning that I've canceled out these ones. I've canceled out this with that, meaning I'm left with, and then you just add up whatever you've left off. So I have my C that gets dropped. I have my 1/2 O2 that gets dropped. And then I have my yield sign that gets dropped. And then I have my carbon oxide that gets dropped. Does this match the top equation? Correct. Now, we're not done yet. Now, we need to find what the question is asking. The question is asking, find the delta H. So, to find the delta H, we need to apply the same things that we did to the chemical equations to the delta H's themselves. So, for the second equation, I know that I flipped this equation, right? And going back to our rules, when you flip the reaction, you change the sign of the delta H. Meaning that I flipped the reaction, I'm going to change the sign of this delta H and make it positive. Then I know at the end, all I did was add up my chemical equations. I'm going to add up my delta H's, meaning I'm going to add negative 393 plus 283, which yields negative 110 kilojoules, and that is your final delta H. Now let's do one last practice problem. This might be a little bit of a more challenging one. Pause it right now if you would like to and do it yourself, and then come back and we'll solve it together. Now let's solve this problem. So this problem is saying find the delta H for C plus 2H2 yields CH4. We have 3 given equations actually. So this one's actually stepping it up a notch, but this one's actually quite similar and actually pretty simple. So my first steps first, I'm going to look at where my things that I need. I know I need a C. I'm trying to look on what side, the right or the left, is my C from my givens. And that way I'll know where to move that, correct? So I'm going to look for any C's. I see that I only have one source of a carbon. That's already on the left-hand side, meaning that I'm not going to change this equation. I want to keep this set in stone because I know I won't need to flip it. Okay, then let's look at my next one. So I need to look for some H2s. Let me look for on what side is my source of the H2s. I see here the only source of H2s in these equations is over here on the left-hand side as well. So I know my H2s also need to be on the left side in my goal equation. That means I'm going to also lock this in terms of flipping. Maybe we might need to multiply later. We'll see. Then the final one, I see that I need to have a CH4 on my right-hand side. Let me look for CH4. There it is right here. But look, this one is on the left-hand side. I need CH4 to be on the right-hand side. So I know automatically I'm going to flip this equation. Now let's rewrite everything, but flip that last equation so we can see where we are exactly. Yields H2O. And then I'm going to flip that last one. So CO2 plus 2H2O yields CH4 plus 2O2. Now let me look at what I can cancel. I can cancel the CO2 with this CO2. I see there's an H. There's an H2 over here. There's also an H2 over here. They're on opposite sides, meaning that I can cancel them out. But wait, I don't have a H2O in my goal equation, meaning that these will need to be canceled out fully. And all the moles need to be canceled out. But over here, there's only one H2O, and over here, there's two H2Os, meaning that I need to multiply my second equation by 2 so that I can make that H2O over here 2H2O. So I'm going to add a 2 over here, multiply this by 2. I'm going to multiply this by 2 and just get a 1. And then multiply this by 2 and get 2H2O. Now I can properly cancel out my H2Os. Now let's see what else I can cancel out. My 2H2, I can't cancel out because that's actually one of my goal over here. So I'm going to leave that be. Now I can see that I can compress these top equations, right? If I add this and I add this, there's one O2 over here, one O2 over here. These both can get canceled out with the two O2s over here because 1 plus 1, you can add them because they're on the same side over here, right? 1 plus 1 equals 2, and then that can cancel out with the 2 over 2 that was over here. Now let's look at what I'm left with. I'm left with my C, my H2, and my CH4, meaning that what I'm going to do, I can rewrite my final equation as C plus 2H2 yields CH4, which was my goal at the top. Now, we're not done. We know this. Now, we need to find the delta H. I'm going to retrace my steps, figure out what did I do to each of my equations, and I'm going to just apply that to the delta H's. I know I flipped this one, so I'm going to flip the sign of this and make this positive. Then I know I multiplied this equation by 2, the second equation by 2, meaning that I'm going to multiply this by 2. That was all the changes that I actually did. So then we're going to combine the delta H's. So negative 393. And I multiplied this by 2, meaning that's going to be negative 286 multiplied by 2, which is going to yield negative 572. And then I know I changed the sign of this plus 890. Yield a total of negative 75 kilojoules. That is your answer for this problem. Thank you guys so much for watching, and I'll catch you in the next one.